So, I appreciate that. On Throwback Thursday, I'll play the throwback song later. My TA gave it to me earlier. The 11th of February, you guys will be able to, how to find the right one, multiply polynomial section 6.6. We notice it's the same as it was on Tuber Day Tuesday because we're still continuing that same lesson, okay? And the same overall objective is to be able to multiply polynomials. So before we had talked about how you would distribute into the parentheses, and on a problem like number 5 that we did together, we said, okay, well, we're going to distribute in the 4x to the first 3, the x to the third, and the last 2. And then from there, we had to make sure everything was in the right order. So we did our underlining and then combined like terms as needed. Well, on 1 and 2, right below number 5 that we did, we're going to be solving some equations, okay? So notice there's an equal sign here. We're not going to let that deter us from what our first couple steps are, though, okay? So we're going to still start off with distributing this x outside this parenthesis. So we're going to do x times x. And what is x times x?
1.
X to the second. Very good. We add those exponents, and there's secretly a 1 on both of those. X times negative 2. What would that be?
Negative 2x.
Negative 2x. Nailed it. And then do we do x times 7x? Do we do x times that 7x? No, because it's not in the parentheses. Very good, very good. So we're just going to put plus 7x. Then I'm going to put that equal sign. And then what am I going to do with this next x we see after the equal sign? Distribute that in, right? So what's x times 4?
4x.
4x. And what's x times x again? That's x to the second again. And then, again, just like before on the other side, we're going to just have minus 9x, just like we had that plus 7x. And then also plus 14.
I have to sharpen.
Ooh, okay.
Oh, we got some like terms.
We do have some like terms. So what are some things on the left side of the equal sign? We're going to focus on sides of the equal sign again. What are some things on the left side of the equal sign we can combine?
2x and 7x.
Very good. That negative 2x and that 7x. What's that give us?
7x.
Ooh, not quite. It's negative 2.
Oh.
Be careful. 5x. Very good. So we're just going to say x squared plus 5x. Remember, when we add and subtract, those exponents don't change. Okay? Equals. What are some things we can combine here on the right side?
4x and negative 9x.
4x and negative 9x. So what's 4 minus 9?
Negative 5.
Negative 5. Very good. So I can put that x squared first, because we know that x squared should come first, right? Because it has a higher exponent. Minus 5x plus 14. If you would rather underline on that part and say, oh, x squared is going to come first, then the 4x, negative 9x, and then the 14, you totally can. Am I saying you have to? No. Am I saying you can? Sure, okay. Giving you guys some choices there. So then, do we have any more like terms on the left side here? Do we have any more like terms on the right side here?
No.
Okay, what have we done when we've gotten to this point before? Does anyone remember?
You do the thing with negative 5 and 5. Separate everything from the x.
Okay, yeah, you get everything away from the variables, or you get all the variables to the same side, right? So there's an x squared on both sides. That's kind of new to us, right? We're going to see what happens, though. So we will end up wanting to move these to the same side, right? Okay, why would it end up being nothing, Olivia?
Because you're subtracting.
That's exactly right, because we're going to end up subtracting x squared to move it across. So we say x squared minus x squared. We'll get rid of that there, and it's going to move it to the other side when we have to do the same exact thing to the other side. But we notice we're going to have the same operation. Positive x squared minus itself is just going to be 0, so we don't have any x squareds left.
So we're always going to subtract them?
If it's positive, then yes. If it was negative, we would have added. We're always going to do the opposite. Yeah. So we treated it kind of the same way as we would have treated any variable. In this case, it was an x squared, though. So now, does this look a lot more familiar to us than for what we've had? Just as nod his head, I would agree with him, okay? What would we do at this point when you have 5x equals negative 5x plus 14, Cheyenne? Nailed it. We would add 5x to each side, because what's going to happen is on that right side of the equal sign, negative 5x plus 5x is 0. So we have 10x, 5 plus 5, is equal to 14. Once again, the exponents don't change when we're adding and subtracting, okay? So now we have 10x equals 14. Ooh, this isn't going to work out cleanly, but that's okay. We can have fractions as answers, okay?
We're not done?
We're not quite done. What do we have to do to get x fully by itself now? divide not by 2, but by 10, because that's what's with the x. Because 10 divided by 10 is 1, or just 1x, which is x. Okay, now I kind of ran out of room, so here's what I'm going to do. X equals 14 divided by 10. Now, does anything go into both 14 and 10? When we have fractions, we like to simplify them. 2 goes into both, right?
Yep.
2 goes into 14 how many times? 7. And it goes into 10, yep, 5 times. So we can keep our answer as 7 over 5 if we want. You can make it a decimal if you want as well and call it 1.4. You would get that by dividing 7 by 5. Or you could call it a mixed number, 1 and 2/5. Once again, those are 3 different options you guys have there, okay?
Do we have to reduce?
Yeah, we do have to reduce. Yep, that's a great question. That's the only thing I'm going to require is that if we keep it as a fraction or a mixed number, that we reduce. Yep. If you wanted to go to a decimal, you could just take 14 divided by 10 if you want, and you get the same thing as 7 divided by 2,
We
though.
have to put x equals in front of it.
Yes, please. Yep. Yeah, go ahead and put x equals. Because what's going to happen is, like earlier, when we had x and y, so that way we already are just clarifying every time. Yeah, great question. Do you have any other questions on number 1?
No.
Okay. So really, the only new math here we saw was those x squareds. But thankfully, those kind of went away anyway, didn't they? Okay, we didn't end up really having to worry about those too long. On number 2, do we think this might be pretty similar, or is it going to be different?
Yes, similar.
Okay, I think it's pretty similar, okay? Mackenzie, can you tell me what my first step might be on number 2? Yeah, we're going to distribute this a. Very good. What is a times a? A to the second. Add those exponents. What's a times negative 4? Negative 4a.
You're so smart.
And then the a doesn't go to the 5a or 2, does it? No, they're not in the parentheses. Very good. So we're just going to keep writing it plus 5a plus 2 equals.
A to the second was 2a.
Nailed it. A to the second. Distribute that. And 2a. Then we're going to have that minus 2a plus 9 there at the end.
Are we going to finish later after lunch?
We have another 15 minutes to lunch, so no. No, we're gonna yeah. All right. So what did we do at this point on the previous problem?
Do the underlining and combining like
Okay, combine like terms. And we can underline if we want. Did I say we have to? No, but if you want to, we definitely can. Give me a hands up if you want to underline. Okay? Okay, it'd be nice. Okay, let's go and try it, okay? And if you don't want to, just don't do it on your paper. That's totally fine, okay? So on the left-hand side, we're going to have those a squared. That a squared comes first. We're going to do different underlines for the left and the right side, okay? So on the 4a, the negative 4a, and the 5a are going to have 2 underlines. And the 2 is going to have 3 underlines. On the right-hand side of the equal sign, a squared is going to have 1 underline. The 2a is going to have 2, and the negative 2a is going to have 2. And the positive 9 is going to have 3.
I thought you were going to change.
Ooh, that'd have been a good idea.
I did my 9 really good.
Ooh, nice.
Love when that happens. I think you get the perfect handwriting. God.
I have a bad habit of my A's looking like 9 sometimes because I'm pretty sloppy with them. Something I need to work on. Yeah, something I need to work on. Yeah, that's a good idea. That's why I started doing my 2s with the little loop is for that reason, so. Really? Yeah, Allie.
Why do parables have to be lowercase letters?
Other things, like capital C stands for something different.
It is true, actually. That's exactly the reason. Because in geometry, where we still use these equations, capital letters mean points on a graph.
It means calorie.
For labels, it can. Yep. So on this left-hand side, a squared, nothing happens with it, so we just rewrite a squared. We notice with the 2 underlines. Oh, thank you so much. I appreciate it.
Yep.
Oh, you too. The negative 4a and that positive 5a combined to be what?
Negative 1A.
It's going to be a positive 1a. Let's say it was negative 4 degrees out like it was the other day. Oof. It's 5 degrees warmer. It's positive 1 degree, okay? And then we're going to have that plus 2. Yeah.
Why don't we ever use capitalize? Is it just because
We just
So that's actually the question we covered a moment ago with in geometry, capital letters are points on a graph. Yep. You're good. So, yep, you could have put a 1 in front of the a. You don't have to because it's implied as well, but if you want to, you definitely can. On the right-hand side of the equal sign, 1 underline under a squared. So it's going to be a squared. 2 underlines under 2a and negative 2a. Hey, what's going to be 2 minus 2? 0. Do we have to write 0a? No, okay. So we're just going to have plus 9. So when we got to this point, notice I'm color coding it, trying to make it the same as the other equation. What did we do at this point?
Subtract the a squared and the other a squared.
Very good, yeah. We subtracted a squared because a squared minus itself is 0, and we moved it to the other side. But it happened to get rid of it on both sides. So we had a plus 2 equals 9. Now, we might notice we actually have 1 less step or 2 less steps here than before. Why do we have less steps?
Because would it be because that one was a 0 up top?
Yeah, that's exactly right, okay? This 2a and negative 2a became a 0a, so we didn't end up having an a on the right side anymore. Whereas before in the other equation, we ended up having still that x with a variable on both sides. So we had to move it across in this step as we went purple to green. But here, there's no variable we have to move across. So what would we do now? Excuse me. And kind of the words ran together there to try and get this variable a by itself. Subtract 2, yep. And then we actually get our variable by itself already, and we get a equals 7. Can you guys tell what that is behind that watermark there? That created it with Doseri. I actually don't know how to pronounce that. Doseri, I don't know. Yeah. What did you say? Dosari? Maybe. I couldn't tell you. Honestly, I've always called it Doseri, but I actually don't know. All right.
I'm going to name my kid Dossery.
All right. Do we have any questions over these two? Alrighty, let's go ahead and move on then. So we're going to learn about this thing called FOIL, okay? So for polynomials, when we have two different binomials, remember bi means 2. When you have two different binomials, x plus 2 is a binomial, 2 terms. X minus 4 is a binomial. That are multiplying together, this parentheses is multiplying with this parentheses. We end up using the distributive property more than once. So what we end up doing is we take this x, multiply it to everything in the second parenthesis, okay? So the x isn't going to multiply with a 2 because it's adding with a 2. The x is going to multiply to everything in that next parenthesis. So x times that x will be x squared.
Why just the x? Is it because it's first or is it because it's a variable?
So it's not going to be just the x. We're actually going to go and do the next thing after. Yeah, great question. And then we're going to do that x times that negative 4, which gives us negative 4x. And then what follows is going to be the next term in the first parenthesis. So we did the first term, the x, to everything in the next parenthesis. Now we're going to go to the next term. We're going to do the 2, and we're going to do the 2 times the whole next parenthesis. So 2 times x plus 2x. And then 2 times that negative 4, negative 8. Is he? Oh, neat. You're good. So now we can go through and we can do that underline thing if we want, or we can just combine like terms as is because it's in standard form right now, okay, highest to lowest exponents. If you want to do the underlines, I know some of us mentioned wanting to do those earlier. The x squared would be first, negative 4x and 2x would be second because the x is the first, and then the negative 8 would be last. What do we notice we can combine here?
4x and 2x.
Yeah, that negative 4x and that 2x. And what do those end up being? Negative 2x. Very good. Negative 4 plus 2. Once again, it was negative 4 degrees the other day. Oof. Okay. It's 2 degrees warmer. It's still negative 2 degrees. It's nicer, but not by much. X squared minus 2x minus 8. What was that last part, Mason, after being weatherman? If this falls through. There you go. I don't understand the reference.
Rusty, he's the weatherman.
Is he?
Rusty Lord.
Oh, I didn't know that.
Imagine naming
He's
your
bald.
kid Rusty.
You just call our Lord Rusty. That's messed up, man.
All right, so we end up getting x squared minus 2x minus 8.
No wonder why he does our church.
Did that make sense or no? Okay, that was new to us, okay? So we have this abbreviation when we do a binomial times a binomial, which we talked about, two terms. It's the acronym FOIL, okay? So a lot of times when you get into later math classes, you said you're doing this science? Yeah, and like the dihybrid crossing, right? Yep, same kind of thing actually, okay? So we have our acronym here. Did you guys use the acronym FOIL?
No.
Yeah.
Okay, some of you guys said, some of you guys didn't.
You did.
Okay,
When?
okay. Okay, so each letter stands for a different word, okay? The first one is the first. So in this case, that was the first in the first parenthesis, x, times the first in the next parenthesis, x. And that was the first thing we did. X times x was x squared.
Optimistic.
Oh, it's not quite optimistic, but it's
Oval.
the outsides. Ooh. Yep. So we say, what's on the outside most on the left side? X.
Outside.
What's on the outside most on the right side? That -4. So x times -4, which gave us our second term, -4x. From Snitch. On Snitch. Then we have the I, like Olivia said, that is the insides. So if we look at this parenthesis as a whole, what's on the inside of this? It's the 2 and the x.
Left.
So we had 2x when they multiplied. And then not quite going to be less, but it's going to be the last. So notice they kind of go together. We have the first and last. We have outsides and insides, okay? The last in the first parenthesis is 2. The last in the next parenthesis is -4. 2 times -4 is -8. So if FOIL helps you remember, great. Use that terminology to help you. If it doesn't, and you're saying, Mr. Costle, as long as I just go through and I say, the first thing was multiplied to everything else. Then the next thing was multiplied to everything else. I'm good. If that works for you, great. If you come up with another way that works, please share it with me. I'd love to know, okay? That'd be really cool. Whatever works for you, though, is good by me. Does that make sense? Okay, am I saying you have to do it a specific way? No, I'm giving you options, okay? I like to give you guys options with these things.
What funny octopuses?
Octopi.
Funny.
Yep. So the last would be the last of each parenthesis. So the last in this parenthesis is 2. It's the last thing you see. The last thing in this parenthesis is -4 because it's the last thing you see in the parenthesis. That answer your question? Awesome, okay. Any other clarification we wanted on this before moving on to using it?
Funny
Okay,
octopi.
12:15.
Right, you had 5 minutes left.
Yeah. Whoa. I mean, it's also true.
This song, I used to think it said Michael Carroll, and that's my dad's name. And my dad's in the military, so my mom used to sing the song.
Interesting. All right, let's look at number 1. Find the product. This is the same kind of setup we had. So you could either follow the FOIL or the other method I was kind of given, okay? Either way is okay. Let's try out the FOIL, though, to start. Just that way you guys can see it in action, okay? So the first of each parenthesis. So what's the first of this parenthesis? X. What's the first of this parenthesis? X. So what is x times x? Not 2x. X squared. You add the exponents when you multiply. Very good. Okay, multiplying and dividing is when you change the exponents, okay? Then next in FOIL is outsides, okay? So what's x and 9? And so that's going to be 9x. Then we do the insides. What two things are on the inside?
4x.
-4 and x. So that becomes -4x. Very good. And then the last. So what are the last things?
4 and 9.
Yeah, that -4 and 9. So what's -4 times 9? -36. Very good.
-36.
-36. Yep.
How does that happen? Is FOIL put it in order automatically? Oh.
Great question. So Olivia just asked, does FOIL put it in order automatically? Okay, this one looks to be in order. Okay, well, so FOIL puts it in order automatically if each binomial was in order. So if each binomial is in order, it automatically puts it in order, and your middle two
I'm so hungry.
are usually going to be combined. We have to double check that they are, but they usually are going to be combined. So what do 9x and -4x combine to be? Yeah, 5x. We have x squared plus 5x minus 36. Once you have that finished, you can kind of get ready to go to lunch here, and we'll go to lunch when that bell rings.
You know how I know
That's what's up, Mr. Cross. Nice to meet you. Let's look at number two. We can foil again, okay? Do you guys want to try foiling or do you guys want to try the loop things? Okay? All right, foil. Let's try foil. Okay. Now, guys, here's the thing. We can do both at the same time. Look at this. The first. What's the first in each parenthesis, guys? A and...
Your mom. Oh,
Nope.
I'm sorry.
What's the first in the other parenthesis? 2A. So it's going to be A times 2A.
Which would be 2A.
Very good. 2A to the second. Okay. Kind of sounds like a French guy saying croissant. Yeah, good luck. Croissant. Okay. To the second. Okay. Now we do the outsides, because foil, okay? If you want to write on your paper, foil, okay, on your test as soon as you get it, do that. On your homework as soon as you get it, do that. On your review as soon as you get it, do that, okay? So, outsides. What's the outside terms? 4 and A. So notice we're going to do A times the next thing, 4. So what's 4 times A? 4A. Mackenzie, what are the insides?
5.
Okay, 5 and 2A. Nailed it. So we do 5 times 2A, and what's that? Anyone? Bueller, anyone? 5 times 2A.
Pack it up, Fish.
Anyone?
Pack it up. Can you play?
5 times 2A.
Can you play the
10A.
Super Good Place to Think of the Future by Les Compounds?
You would need to ask me that again when I'm able to read it.
Board?
5 times, not right now, you're supposed to be reading on this, okay? 5 times 4. Yeah, the last of each frequency, 5 times 4. 5 times 4, 20. Notice, this is in order still. So what do we need to combine though?
Like terms.
Like terms, what are the like terms?
10A,
4 and 10A, they're combined to be
14A.
14A. 2A squared plus 14A plus 20. Is this already in order right now?
Yes.
Dink, dope, and lady. All right. I want you guys to try number 3, okay? Go ahead and try this one on your own, please and thank you. When you have it or have questions, raise your hand. I saw some things that we could use some feedback on as well, okay? So, here, we can do our first, okay? We're seeming to like the foil thing as I'm kind of looking around. That's what it seems to be. And if you, once again, you want to do the first thing times everything in the next parenthesis, and the second times everything in the next parenthesis as well, both are perfectly good ways to think about it, okay? Or once again, if you come up with another one, I'd love to know it. Y times y is y squared. Y times negative 8 is negative 8y. 8 times y is 8y. So that was our outsides and our insides. Now, some of us missed this one as we went around. Our last. Positive 8 times negative 8, okay? So remember, we're multiplying here, so that's not going to be 0. It's going to be a 64. In this case, a negative 64. Now, as we combine like terms, what do we notice is kind of special about this problem?
The two Y's are in the same area, right?
Okay, those y's are right next to each other again, okay? That kind of happened in the last two as well, which is really convenient for us. What do we notice about negative 8 and positive 8? What's going to happen with those? Yeah, they end up zeroing out, okay? I'd rather let's try to use the word zero than cancel, just because I think it communicates it better mathematically. It doesn't happen, okay? So negative 8 plus 8 is 0. We don't have to write 0y. So it's just y squared minus 64, and that's it. That was a really bad squared. That's better.
I did it.
Any questions on these 3? Okay.
I have a question before you delete that. Can you make that one a square, not a circle, because it's gone?
Oh, that's fair. I'm going to rewrite my squared as while I'm at it. Yeah, no problem. That is kind of weird. There's honestly just no rhyme or reason when I do a rectangle versus a circle. I just kind of randomly do it, and like I'll like look up and like at the end I'm like, oh, they're all different. Or like a student will ask like, why are these 3 this and these 3 that? I'm like, honestly, it just kind of happened. So yeah. What's up?
Where'd you get the -6?
Oh my gosh.
Great question. So 8 times negative 8, the last of this parenthesis, 8 times 8 is 64, but a positive times a negative is a negative.
I'm like,
No, they wrote this song when they were on
Okay.
Zoom.
Does it make sense that you would do 8 times 8? Okay. Does it make sense that 8 times 8 is 64? Okay. Does it make sense that positive times a negative is a negative? Okay. So that's how we get negative 64. Okay. All right. 3 more problems. Okay. And then we're done with the section. Okay. Number 4. Can somebody help me with this?
No, thank you.
Okay. Mason, you already started? You want to help me with this? Oh. Write it like on here? Because COVID, I just don't want to change them around.
You know what? You do
Okay. This.
Yeah.
Okay.
And it's 10x.
Nailed it. Okay.
Then it's minus 45x.
Okay.
Then
Yep.
negative 8x.
Yep.
And then I didn't know, but I just said plus 36.
Ooh, you're right. It is positive because a negative times a negative is a positive. Very good, very good. All right. Now, do we have things that we can combine here again? Yeah.
45x and 8x and
Yeah, you're right. And those are the same sign. So we keep that sign as negative, but we make it bigger. So it's going to be 10x squared minus something. Minus what?
minus
I heard it?
53.
53. X plus 36. I don't think I have room to write in minus what Olivia said, but I can try.
Oh my goodness, write it.
All right. Any questions on number 4? Okay, so I don't know if you guys are noticing a theme, but how many different things, I should say, do we end up with after we go through every time? 4, and then every time it's been that we simplify down to 3, right? Might be a pattern we're kind of noticing, okay? And that won't happen 100% of the time, but probably like 90% of the time. So it's going to happen pretty often, okay? Now here, do we notice any sort of difference between 5 and the first 4 that we had? There's an extra one in the second parenthesis, right? Now we have something squared in here, okay? It's going to be slightly different, okay? So this second parenthesis has 3. So will FOIL necessarily work here? No, because we have more than 4 different things. So you can't say first, outside, inside. It doesn't really work anymore. But the same idea still holds true. We're still going to take this first thing, 2y, and we're going to multiply it to everything in the next parentheses. So it's still going to be 2y times 3y squared. That was like the worst loop I've ever made in my life.
What?
That was better. 2y times 3y squared. What would that give us?
3 thirds.
Yep, very good. 6y to the third.
Cute,
Oh
right?
my god.
Yep, that'd also be cubed. Yep.
Wait, this is just like oh,
Yes. 2y times 4y. So you go to the next thing. So still, everything needs to be multiplied by 2y in that parenthesis. So we're just going to the next thing. So 2y times 4y is 8. Very good. 8y to the second. And then we do 2y. There's still one more in that parenthesis now. Times 5. So what's 2y times 5? Okay, very good. 10y. Now, we did 2y times everything in that second parenthesis, right?
yeah.
It's not going to multiply with this 5, though, in the first parenthesis because they're adding, okay? What do I need to do next? Does anyone have an idea? Yeah, distribute the 5. We're going to do the same thing. 5 times all of those. So it's 5 times 3y squared. What's that going to be? 15y squared. Okay, it's going to be squared this time because there's no y on the 5. And we have a y squared on the 3, okay? So now we're going to have 5 times 4y, the next thing.
20y.
And that's going to be 20y. And then we're going to... Go ahead.
25.
And then 25. Ha ha ha. 5 times 5. Good old SpongeBob. Okay, we ended up with 6 things this time, right? If you count them all out, we should get 6 things.
Yep.
Okay? Now...
The end, like, last part, I can't read.
Oh, plus 25. Yep, great question. Thank you for asking instead of just being confused. I'd much rather have that. Yeah. Alrighty. Now on this one, it would maybe be better to do our underlining?
Yeah.
I think so, because some things kind of got out of order this time, okay? So Olivia was asking, are they always going to be in order? When we have the 2 in order and 2 in order, they are. But now we have 2 and 3. So even though they're still in order inside the parentheses,
So,
we got out of order a bit.
we need to combine 8y to the second and 15y to the second.
Okay, those are going to combine. But what's going to come even before those y squareds?
6y.
6y to the third. So then those 8y to the second and then 15y to the second will have 2 underlines. Okay. So we got
And then
our first and our second taken care of. Yeah, Rochelle, what's going to come third?
3 lines is going to be 10y, 20y.
Nailed it. And then we only have one thing left, right?
4 lines on 25.
Very good. Any questions on how we got these? Okay, Olivia.
I still have a question on how we got them.
Sure.
But is it okay that the first one I put 1 line,
Yep.
second one I put 2 lines,
Yep.
the third one I just put triangles underneath them,
Okay.
3 sides, and the last one I only draw a circle.
Oh, okay. So Olivia's saying, "Hey, Mr. Costle, I have this method that works for me." Okay, and that's gonna be perfectly fine. Okay, to answer your question right away, I do a triangle underneath a third thing because there's 3 lines to a triangle. Okay, does that correct me if I'm wrong? Are you doing that so that way all the lines don't start running together? Yeah, to make it differentiate. That's a good idea. Okay, and then she was saying the last one, so she did a triangle under those last 2.
You could do a square.
And then you could do a rectangle or a square for that. Or she said the last one, I always do a circle. So is it the circle whatever one's last?
Yeah.
And so that way you just know you're done? Okay, cool. So if you want to do this way, that's perfectly fine. Yeah. Anyone have any questions on what Olivia's kind of getting at there? Alrighty. So let's go through and say, okay, well the first thing, 6y to the third. There's only one thing with that underline. So it just stays that. The second thing, Rochelle had mentioned we need to combine the 8 and that 15y squared, okay? Please put that away.
23.
Okay, very good. It's going to be 23. And it's going to be y to the second. Remember, those exponents and variables do not change when we're doing adding and subtracting.
Plus
Now-
2y.
Yep. And before that, I'm just going to go and recap that if you want to cross the ones we've used out, you can. I would recommend lightly doing that, though, so it's not like incredibly blacked out. And then 10y plus 20y would be 30y. And then we have that plus 25 at the end, okay? Ooh, teamwork. Now this is in order, and it's all taken care of. Questions on that?
We don't want to solve it. Oh,
Yeah, it is. It's already in order, yeah. Yeah. That was the nice part. That's why I really like kind of the underlining thing, or as Olivia's introducing kind of the triangle and circle thing as well there, is it takes care of 2 steps at the same time, and it keeps us very organized. And
I would have knew this in like 8th grade last year.
you said you remember doing it in 8th grade last year?
No, I said I wish I knew that so I didn't have to take 5 years on one drop.
Oh, yeah. That's fair.
I just didn't like our last year teacher.
Yeah, me neither.
Ooh. I won't share this video with her then.
Video?
I mean, I'm recording my lesson.
Oh.
Mhm.
Actually,
Yeah, it's recording right now.
Hear everything we're saying.
I'll post it on my YouTube video, but only students that miss it really go back and watch it. What?
Hi, everybody online.
Yeah. So it doesn't always pick up what students say just because the microphone's on this. Yeah.
Yeah, last year.
It's not a squid, Justice.
He recorded one of the videos and like 3 people sneezed and there was a whisper from my
Yeah. So last year I was recording on my laptop, and for some reason it picked up the audio better from students sometimes. But yeah, now I'm using the iPad, so it picks up differently, I think, a little bit. But yeah, you sometimes like louder things like a sneeze, so you can hear. But yeah, isn't that kind of funny? Like when you hear those things, like, oh, don't want to hear that. But anyway, yeah,
I like it.
yeah, I think she's pretty cool. But all right, on number 6, this is our last one before we're done for the notes. What's it for on number 6?
The 8 and 3.
There's 3 things in each parenthesis, aren't there?
I'm so excited.
Okay, there's 3. Okay, on number 5, there's 3 things in one of the parentheses. Now we're doing 3 things in each parenthesis. Okay. Once again, this really won't change what we're doing. Okay, too much. We're just gonna kind of expand what we were doing. So, okay. Do you need another piece of paper? Maybe we could staple it to it. Okay.
I'll just write the answer down.
Ooh, okay. Maybe write down some of the work and then write the answer. That might be a good idea. Alrighty, so we're still going to take the very first thing. That's pretty cool, okay? I mean, it's pretty cool, but let's put it down for now, okay? So we're still going to take the first thing and multiply it to everything in the next parenthesis, okay? So we're going to do x squared times 3x squared, and what's that going to be?
3x to the 4th.
Very good, 3x to the 4th, okay? I would start pretty far to the left, guys, on writing this, okay? Because we're going to have a lot of things here. We're going to have 9 things we're writing here. It's a lot, right? Yeah, Mackenzie just made it look 9. Okay, yeah, we're going to write 9 things here, okay? If you need to write smaller, feel free to write smaller as well, okay? I'm just warning you ahead of time. X squared times the next thing, 2x. What's x squared times 2x? I heard it? 2x to the third. Very good, very good. Then x squared times the last one in the parentheses, 5.
Is the third.
Not to the third, but yet squared.
No.
Very good. An x squared and no x's, so x squared. Now we're going to go through the same thing, but with which thing now?
X.
With x, right? The second thing. Does anyone know what we're going to do after that? The same thing with the 5. Okay, so it's really just like what we're doing here. It's just you have one more thing to go through with. So x times 3x squared.
3x to the third.
Nailed it. 3x to the third. X times 2x.
3x.
Not quite.
X to the first.
There you go. 2x squared. And then x times 5.
5.
5x. Okay. It might help if I change colors here. Okay, you're lost.
I can't read the green for some reason.
Okay. Do you want me to read them to you to make sure you have them? Okay. So this is 3x to the 4th. Do you have that?
I totally wrote all of these letters wrong.
Also, she's kind of dyslexic.
Okay.
Nathan.
Okay. Well, yeah, I can. Let's make sure you have what we have up here.
So I
Okay.
have 3x to the fourth
Yep.
plus 2x to the second.
That should be 2x to the third, real quick. Okay. Yep. What do you have next?
Just the plus sign.
Yep.
Just the plus sign after the 2x to the third.
Okay, and then you need what's after that.
Yes.
Okay. 5x to the second
Okay.
plus 3x to the third
Okay.
plus 2x squared plus 5x. That's what we have so far. Then we're going to go through and we're going to get 3 more things. Okay. Will it be okay with you guys if I change colors so we can kind of see what's happening with this last one?
Yes.
Okay. Maybe I should have changed colors for the middle one too. All right. 5 times 3x squared would be what?
15x.
15x squared. Very good. I'm running out of room. 5 times 2x.
10x.
10x. Guys, I ran out of room. Here's what I'm going to do. When I do my 5 times 5, I'm going to go and I'm just going to write it underneath because I don't have anywhere else.
See, that would be so confusing.
Why don't you just
Okay.
erase what you had in a 5? Or just like right underneath it.
I
I can't read my own handwriting. 'Cause
Say
I
that again.
Small.
Yeah, explain to me.
Oh my goodness, not that.
No.
Anyways, so like,
It's like a very
you could have like, taken whatever like equals there and put it underneath here.
Oh, that'd be a good idea.
You could have room, Nathan.
That'd be a good idea. Maybe I'm going to do that in the future. Yeah, that's fair. All right. So now we're going to go through and we're going to underline again. Whew. Okay, thankfully these are all x's, so we don't have to worry about alphabetical. What's the highest exponent we see? 4. That's going to have one underline. And let's go through. Do we see any other x to the 4th real quick? No, okay. Mackenzie, what's the next highest power you see after 4? 3. Okay, so how many underlines is that going to have? Okay, 2. Now, do we see any other powers of 3? Yeah, so that's going to get 2 underlines as well. Do we see any other powers of 3?
No.
No? Okay, so we're done with those.
I'm like so sweaty. I don't know if it's coffee or what, but I'm just like, oh my lord.
Ooh, there you go. There you go. All right, what's coming third? Yeah, those powers of 2, okay? And so we could do those triangles like Olivia was doing. I'm going to try that here because it makes it look different. We have 3 different things coming in, okay? Now you might notice we only have 3 different terms left. Okay, 3 different terms without something underneath them, okay? So we're doing our 4th term. So as Olivia was saying, hey, I'm going to do the square because that's 4 sides, okay? If you want to do that, that's awesome. What am I going to put a square under?
The one with just X.
Yeah, the ones with just x, so that 5x and 10x. And then what, Olivia, what would you put under the 25 you said?
The circle.
The circle, that way you know you're done. Okay, so whatever system works for you, great. If this shape system that Olivia's kind of introduced and works for you, great, do that. If that doesn't work for you and you would rather do the line still, great, do that. If you have another system entirely, great, do that, okay? Whatever system it is, That sounds great to me.
I wanna be.
All right.
3.
So we're doing the first thing we're writing. How many things have one underline for the first thing we're writing?
1.
Just one. So we're just going to write that part again. 3x to the 4th. I'm going to put a light slash through to know we're done. That might be really helpful in this one. Now we're on to our second thing. So how many underlines are we looking for?
2.
2. Now we have 2 different things. So 2 and 3.
7x to the 5th.
Oop, be careful. We have 2 and a 3.
Oh,
5.
you get the 5.
Yep, and it's 5x to the 3rd. Remember, those exponents and variables don't change when we're adding and subtracting. Now I'm going to go ahead and cross those out so we can just visually see, okay, the first one we don't have that does not cross out is 5x squared. And we're on to 3 things, so we're going to look for 3 underlines or 3 lines with a triangle. How many things have that triangle? 3. 5 plus 2 plus 15.
22x squared.
That will be 22x squared.
Okay.
Remember, variables and exponents are not changing, so we're going to cross all 3 of those out because we used all 3 of them, okay?
Wait, we don't add the exponent. We add the exponent.
Only when we multiply and divide. Yep, yep. Now, we're doing our 4th thing. 1, 2, 3, 4th thing. So we're looking at our 4-sided figure. 5 and 10, very good, is 15x.
Plus 25.
And then we have only one thing left, the circle, plus 25.
So we're done.
And that is it. Do we have any questions on that? Okay.
Those ones on the wall.
There's none that there is one that is that big. Number 19 is that big. All right. Any questions on any of these problems other than what's been asked? Okay. I do want to highlight, guys, on number 20. Okay, let's talk about number 20 just real briefly here.
Can we just not do that?
No, we're going to do it, but we're going to talk a bit about it.
Are we going to do it to all 3?
So here's what you would do for number 20, okay? So this is the same worksheet we had before, okay? Allie, thank you. Yeah. This is the same worksheet as we had before. Can you get it out? Okay. We said it was at home. I'll give you another one. Okay. You can staple them together later. Okay. So we're going to ignore the fact that this third one exists for a moment. You guys remember doing that before?
No.
Okay, we said back a few sections ago, I think it might have been actually before our last test we did something like this on, where we had and I gave the example where if you have like a 3 times a 4 times a 5, you would do the 3 times a 4 and call that 12, and you just kind of pretend that 5 doesn't exist for a half a second, and then you bring the 5 back and have 12 times 5 and say, oh, that's 60. And you multiply all 3 together. Same idea here. You just pretend m plus 5 doesn't exist for a second, and all of a sudden, is this a problem we've done now? Yeah. And after you do this problem, and you combine like terms and everything, you'll have 3 terms. And then you'll do your new 3-term thing with your 2-term thing. So you'd end up getting something like, you don't get this, but you get something like scribble scribble plus scribble scribble minus scribble scribble and m plus 5. And then you would do this new problem here, just like we've been doing our problems, okay?
Could we do it the other way? Like,
The last 2?
when it's the last ones, like the scribble ones, could
Yeah.
we flip it to where you do the 5 and the m and multiply it over?
Sure, yeah, you could do the m plus 5 and have that parenthesis go first. You could do that. Is that what you're asking? Yep. Yeah. All right, any other questions before I say, hey, let's work on our homework?
No.
All right, well, hey, let's work.